Welcome to Concepts in Chemistry. In this talk, we will discuss the relationship between pressure and volume of gas. What's the relationship between pressure and volume of gas? The pressure of gas is inversely proportional to the volume of gas. This means that as we hold temperature and amount of gas constant, as the pressure of gas molecules increase, the volume of gas molecules decrease. Mathematically, we can write this relationship called Boyce Law as P is inversely proportional to 1 over V, where P is the pressure and then V is the volume of gas. To visually illustrate this, let's take a look at this picture. So here I do have a metal cylinder. In this metal cylinder, we have gas molecules in it. So the blue circles you see here depicts gas molecules. As you can see, we do have lots of empty spaces between these gas molecules. Also, to apply varying pressure, we are going to put varying weights on the piston of this cylinder. So just observe, as we vary the weights on the pistons, the pressure also varies. So which means that as the pressure goes from 40 to 80 kilograms, you notice that the piston drops and the spaces between the gas molecules decreases. So meaning that the volume of gas molecules decreased. So what we can say is that as the pressure increases, the volume of gas molecules decreases as well. And the reason is that we do have lots of empty spaces between these gas molecules. So as we apply pressure, we are decreasing these spaces between the gas molecules until such a point that the gas molecules starts pushing back. So as you can see here, in this third cylinder, you can see that the gas molecules are already constrained in a very tiny space. Okay, so this empty spaces between these gas molecules has been reduced to a point that the gas molecules start pushing back on the weights. Okay, so but clearly, as you can see, as pressure increases, volume of gas decreases. Okay. So how do graphs of pressure versus volume look like? Usually when we plot pressure in atmospheres versus volume in liters, we usually get a curve like this. So clearly, as you can see, as the pressure increases, the volume of gas decreases. And as the volume of gas increases, pressure decreases. Okay. Similarly, we can plot a graph of pressure in atmospheres versus the inverse of the volume. That is versus 1 over V. And once we do that, we get a straight line. So this straight line tells us that as the pressure increases, the inverse of the volume of the gas also increases. Okay. Now let's try to solve this problem related to Boyce Law. The question says, at constant temperature of 35 degrees Celsius, a sample of gas occupies a volume of 5.0 liters. And has a pressure of 2 atmospheres. If the volume of the gas decreases to 2.0 liters, calculate its new pressure. So to make sense of this, we do have an illustration here. So we do have this same gas at 2 different conditions. So the first condition is that the gas has a volume of 5.0 liters and occupies a volume of 2.0 atmospheres. And the second condition is that this same gas occupies a volume of 2.0 liters. But now we are asked to figure out the pressure of this gas at condition 2. So to do this, let's go back to the relationship between pressure and volume. From Boyce Law, we know pressure is inversely proportional to volume. So what this means is that as the pressure increases, the volume decreases. We can remove this proportionality sign and introduce an equal sign, a constant. And to do that, we'll say P is equal to what? K over V. Okay. Now, we want to isolate K. We want K to stand alone. So what we'll do is that this is the same as saying P over 1. So we cross multiply. So if we cross multiply, P times V, K times 1. So that'll give us PV equals to what? K. So this is another way of expressing Boyce Law. Okay, so it says that pressure multiplied volume is equal to what? Constant. Okay. Now, since we have the same gas at different conditions of volume and pressure, it means that we can say that under condition 1, the pressure of the gas is P1 and the volume of the gas is V1. And this is equal to what? Constant K. And this constant is also equal to the pressure of the gas, which we call P2, and the volume of the gas, which we call V2 of condition 2. Okay. So clearly, as you can see, we can remove the constant K and equate the two sets of conditions. Okay, so we can say P1 V1 equals what? P2 V2. So this is another way of expressing Boyce law for a gas at two different sets of conditions. Okay, so we can now solve for the missing pressure. Okay, so our P1 from condition 1 is 2.0 atmospheres, and our V1 from condition 1 is 5.0 liters. Okay, and our P2 from condition 2 is unknown, which is what we want to find, and our V2 from condition 2 is 2.0 liters. So we just plug in the values and then solve for P2. So we say P1, which is 2.0 atmospheres, times V1, which is 5.0 liters, is equal to P2, which we don't know, times V2, which is 2.0 liters. Okay. So we want to solve for P2, so we divide here by 2.0 liters and then divide here by 2.0 liters. Whatever we do to the left, we do to the right. So this will cancel that. Okay, then units liters will cancel liters. So our pressure, of course, will be in atmosphere, which we want. Okay, so 2.0 will cancel 2.0 as well. So that means that our P2 is equal to what? 5.0 atmospheres. So that is our unknown pressure. Okay, so that is how to apply Boyce law to solve for any of the variables in the formula. Okay, so once we have the same mass of gas at two different conditions, you'll be able to solve for a missing variable if you know three of the variables. Okay, so as you can see, P1 V1 equals what? P2 V2. So if you know any of these three variables, you'll always be able to solve for